Hello and welcome to my channel. I'm excited to share my content with you. Mojo language marries Python and MLIR for AI development. New programming language aims to combine full Python compatibility with low-level programming features, along with the ability to harness GPUs and other AI accelerators. AI infrastructure company Modular has launched Mojo, a programming language for AI developers that aims to combine Python usability and full compatibility with the Python ecosystem with C performance. Low-level systems programming and advanced compilation features come by way of MLIR. Unveiled May 2nd, Mojo is intended to bridge the gap between research and production, leveraging Python syntax as well as systems programming and compile-time metaprogramming. Modular bills Mojo as faster than C, more hackable than NVIDIA's CUDA, and as safe as Rust. Mojo began with the goal of bringing an innovative programming model to accelerators in machine learning. But because today's CPUs also have Tensor and other AI accelerators, Modular decided that Mojo should support general-purpose programming and, because Python is so widely used in machine learning and elsewhere, to embrace the Python ecosystem. The embrace of Python also simplified design efforts, with most of the syntax already specified. The company could instead focus on building the compilation model and designing specific programming features, Modular said. Mojo is intended to be a superset of Python and compatible with existing Python programs. Python core features are supported such as async/await, error handling, and variadics, but other aspects of Python, such as classes, still are missing. Goals of the language as a member of the Python family include full compatibility with the Python ecosystem, predictable low-level performance and low-level control, the ability to deploy code subsets to accelerators, avoidance of ecosystem fragmentation. The Mojo standard library, compiler, and runtime are not yet available for local development. Modular has created a hosted development environment to try out Mojo, the Mojo Playground. Developers must sign up for access. The roadmap for Mojo includes features such as tuple support, which is partially implemented now, as well as keyword arguments and functions, improved package management support, and standard library features such as canonical arrays and dictionary types. Full support for dynamic features in Python classes also is eyed, as is C/C interoperability. Mojo is not the only attempt at solving the Python performance and deployment problem. In terms of languages, Julia is perhaps the strongest current alternative. It has many of the benefits of Mojo, and a lot of great projects are already built with it. The Julia folks were kind enough to invite me to give a keynote at their recent conference, and I used that opportunity to describe what I felt were the current shortcomings and opportunities for Julia. As discussed in this video, Julia's biggest challenge stems from its large runtime, which in turn stems from the decision to use garbage collection in the language. Also, the multi-dispatch approach used in Julia is a fairly unusual choice, which both opens a lot of doors to do cool stuff in the language, but also can make things pretty complicated for devs. In Python, the most prominent current solution is probably JAX, which effectively creates a domain-specific language, DSL, using Python. The output of this language is XLA, which is a machine learning compiler that predates MLIR, but has the huge upside that it doesn't require a new language or new compiler. But I'd much prefer to use a language that's as elegant as Python and as fast as expert-written C, allows me to use one language to write everything from the application server to the model architecture and the installer too, and lets me debug and profile my code directly in the language in which I wrote it. How would you like a language like that? That's all for today's video.